product of these two, f of beta 1 into f of beta 2 is less than 0. So if f of beta 1 and f of beta 2 is less than 0, opposite sign, they are in opposite sign, then this polynomial has at least one real root between beta 1 and beta 2. At least one real root, it may be more than that. So if f of beta 1 and f of beta 2 is opposite sign, that means f of beta 1 into f of beta 2 is less than 0. In that case, definitely any degree polynomial, either this fifth degree, second degree, third degree, whatever degree polynomial, if it satisfies two values of f of x which are less than and greater than opposite sign, hence that function or that polynomial having at least one real root between the two values beta 1 and beta 2. At least one real, definitely you get, because it crosses the x-axis, means it will cut the x-axis, then we have, let us say that root is alpha. It may be more than two root like this. In that case, we get more than one root also. But I said at least one root between beta 1 and beta 2. That's general idea. An example you see. F of x, if, see this example, if a less than b less than c less than d, a less than b less than c less than d, and f of x is equals to x minus a into x minus c plus 2 into x minus b into x minus d. The question is, prove that f of x has real and distinct roots. Prove that f of x has a real and distinct root. So if you expand f of x, you get a quadratic equation. It is a quadratic equation. It has at most two roots. Either two roots or less than two roots. Here roots means real only. This is a quadratic equation. This is a quadratic equation. The sum of the quadratic equation is again quadratic equation. Hence, it is the second degree polynomial. It has at most two real roots. It don't have more than two real roots. That two real roots are real and distinct. You must prove. That means what we do generally, we do this, expand this, and adding them. Discriminant is greater than 0. That's our idea, right? So it is okay for the quadratic, but what about the third degree, fourth degree, fifth degree polynomial? How to approach if like this conditions are there? Clearly, you see here what I am doing in the solution. F of a I am substituting in this question. Substitute a here. A minus a 0. This quantity is 0. 0 plus 2 into a minus b and a minus d. A minus b into a minus d. So a minus b, take this b this side, a minus b is more than a. So it is less than 0. Similarly, a minus d also less than 0. Less than 0 into less than 0, negative into negative become positive. It is greater than 0 now. Similarly, I'll find out f of b. Put f of b here, it is 0. And it is b minus a, b minus c plus 0. B minus a, b is more than a, then it is greater than 0. And b minus c, which is less than 0. So finally it is less than 0. It is positive, it is negative. Positive to negative, negative. Similarly, f of c you substitute. F of c, if you substitute c minus c, this is 0. Plus here 2 into c minus b, c minus b, c minus b, c minus b. Now C minus B is positive, but C minus D is negative. Positive into negative, negative.
Negative.
So similarly, f of D you substitute. This is a D minus A, D minus C plus 0. See the D minus B is the larger number. If you subtract A or C, you get both positive. Positive into positive.
Greater than 0.
Now you draw the real axis and look at the point A, B, C, and D. So, as we discussed, Wavy-Coe method. So after D, if I substitute D, I am getting the positive. So here above, because f of D I am getting positive value. What about f of C? F of C is a negative value.
Negative.
Now you see f of D and f of C are opposite side. Then the curve crosses the x-axis between C and D. Curve crosses. This is the curve actually. The curve given curve this f of x. F of C negative, f of D positive. So definitely the curve crosses the x-axis between C and D as I discussed the previous concept. Now f of B is what? Negative. F of C is also negative. Curve will not cross between B and C. Between B and C, curve will not cross the x-axis. Then it is below the x-axis. Next. F of B is negative, but f of A is positive. F of A and f of B are opposite side. Curve must be crosses between A and B.
And
Curve must be crosses between A and B. Now see, the curve cuts the x-axis. This is the x-axis. Curve cuts the x-axis in 2 points, which are between A and B and between C and D. So hence we are getting the 2 roots of this equation which are distinct, this one and this one. One root is between A and B, other root between C and D. Like this we can approach the conceptually. To understand f of A and f of B are negative, f of A into f of B are negative, then there definitely one root between A and B.
Sir,
Given the concept in terms of beta 1 and beta 2. If f of beta 1 into f of beta 2 is less than 0, then there must be a root between beta 1 beta 2 of f of x. If f of beta 1 and f of beta 2 both product is greater than 0, the curve will not crosses the x-axis between the beta 1 beta 2. Hence, we don't have real roots in between that values. So with that concept, I got that f of A and f of B are opposite side. Definitely, I have one root between A and B, and f of C and f of D are opposite side. That's why I have one more root between C and D. I can say the root is where the root is located. According to everything is unknown here. A, B, C. We don't know, but we know that they are in ascending order. And we can say where is the root. One root is between A and B, other root between C and D. Hence, we can say. Like that, there are many concepts related to the polynomial. The extension of this concept, like if it is an odd degree polynomial, we have at least one root. If it is an even degree polynomial, the roots it depends on the leading coefficient and the last term. All these things in the theory of equations in detail I will discuss later. So the basic things, at least by the graph ideas, this much is enough in the polynomial, and division algorithm is there. That one also discuss. I'll start the new chapter, that is sequence and series progressions. Okay.
and
New chapter, sequence and series. Sequence and series. Right. What is the sequence? Let us see the definition of sequence first. Already, maybe the basic thing, the basic part Professor has explained that the function. Let me give the direct definition by using the name by using the word functions. Sequence is a function. What is the function? If you want to know the function definition, you have to know the set definition, relation, ordered pair, everything you have to know. So leave it if you don't know the function definition. Okay. This definition is not useful for us. The sequence definition. At least you have to know the definition. The sequence is nothing but a function whose domain is set of natural numbers, it is capital N. Domain, range, everything you read. Just if you know that, then see, otherwise just write down the definition in detail. That once again we'll repeat this. And range is the subset of real numbers, which is capital. A function, sequence is a function. Sequence is a function whose domain is set of all natural number and whose range is subset of real numbers. For example, 1, 3, 4, 5, so on. This is one of these sequences. Usually we denote that the sequence with AN, that's a notation. Sometimes you can denote with this bracket AN, and in some books written like this, sequence of n terms. AN is equals to 2, 4, 6, 8, like this. These are the sequence. And sequence, no need to follow some certain pattern. Here I written 1, 3, 5, something like that. And here 2, 4. It is not necessary that the common difference is a constant, common ratio is a constant. It's not necessary. But it should be defined with a nth term. It should be defined with a common term. With nth term, you can say. Next definition is series. If A1, A2, A3, so on in sequence, A1, A2, A3, so on, are sequence, then A1 plus A2 plus A3 plus so on is series. That's series definition. Generally, you denote that sum of all sequence as series. If the sequence terms are finite, series is finite. If the sequence of terms are infinite, series is infinite. Simply that definition. And sequence of function is not defined with any it has a nth term. 2, 3 example I discuss. I'll give the nth term, you may write a sequence. And you can write the series. Okay? First, let me give the examples of find example 1. You see, find the sequence. Find the sequence whose nth term is given by 2 questions. First question is an is equals to 2 power n by n. Second question. AN is equals to
Sir, your
2
video is
power n minus 1 power n by n.
the video is blurred, sir.
No, sir, it's clear.
Sir, example of series.
Right. So first question you see. Let's write the series sequence. Sorry. So take 1 A1. We get that 2 power 1 by 1 is equals to 2. A2 2 power 2 by 2 is equals to 2. A3 2 power 3 by 3 8 by 3. A4 is equals to 2 power 4 by 4. What was this? 4.
4.
So since the answer is 2, 2, 8 by 3, 4, so on, is sequence. Is the sequence of the given nth term. Similarly, you find out the second sequence, second nth term sequence.
Yes, sir. Yes, sir.
In the same way, sir.
Yeah, same way. Find out the sequence. For the sequence, nth term is given, you find out the sequence.
Sir, 2, 5, 26 by 3.
2, 5.
Second
Yes,
question.
sir. 2, 5.
5, 26 by 3.
26 by 3.
26 by 3, so on.
This is the
82 by 4.
sequence. This is the sequence of the second nth term. Now do this one third. An is equals to 1 by n. N is odd natural number. 1 by n. N is even. N belongs to the natural number. Of course, you know the n belongs to the natural number because I said domain is all natural number. What is the sequence? Third one. For
Sir,
substitute
n is,
N1,
then n is odd.
here, sorry, here minus 1 by n.
1 by 3,
1 by 3, 1 by 3, 1.
Here minus 1 by n.
1 by 5, 1 by 7.
And so on.
Changes sequence is for the third question. First substitute 1 equal substitute here. 1 by 1 is 1. 2 equal substitute here. Where? Here.
Minus 1 by 3.
Even.
Minus 1 by 2. Next.
1 by 3.
1 by 3.
Minus 1 by 4,
4.
1 by 5, so on.
1 by
So if nth term is given, how to find the sequence? I'll have to understand. Yes or no? Write down the next question. Next, actually, there is a name for this Fibonacci sequence. Write the example. Example 2. Write first 3 terms of the sequence. Write down the example. Write first 3 terms of the sequence. First 3 terms of the sequence. Write first three terms of the sequence defined by A1 equal to 2, an plus 1 is equals to an plus 1 is equals to 2 into an plus 3 by an plus 2. Write the first three terms of this sequence. So you have that A1 anyway. So substitute N2. So from this N1 and 1 substitute 1 plus 1 is equals to 2 into A1 plus 3 by A1 plus 2. So A2 is equals to how much then? 2 into 2 plus 3 by 2 plus 2. How much? 7 by
7 by 4.
4.
Substitute N2. A2 plus 1.
Plus or
2 into A2 here. N is 2 now. Plus 3 by A2 plus 2. So 2 into A2. A2 is what?
7 by 4, sir.
7 by 4 plus 3 by 7 by 4 plus 2.
2.
4 LCM. 4 3 is 12. 12 plus 14.
26.
Divided by 4 to is 8. 15. Is it? So since from this A2 value is 7 by 4 and from this A3 value is
26 by 15.
26 by 15. Next n equals to 3, substitute and find out A4 value. Tell me A4 value. What is the A4 value? First three you said no in the sequence A2, A3, A4. Twenty-seven
99 by
by
56.
57 by 50.
97 by 56.
97 by 71.
ఒక్కొక్కరు ఆన్సర్ చెప్తున్నారు. 97 by 56 అంట. అవునా?
by 71.
Okay, you try this latter. Next question, write down. Next example 3. Sequence defined by an equals to an square plus bn plus c. A1 is equals to 1. A2 equals to 5. A3 is equals to 11. Then find A10.
Once again, this is the question, sir. An is equals to
An is equals to A into n square. This is an. A into n square plus bn plus c, then a1 is 1, a2 5, a3 11, then find a10. First, find out small a, small b, small c. Try చేయండి.
So 36 is
Sir, you are in mute.
Sir, you're muted.
Substitute 1 first. 1 is equals to a plus b plus c. First equation. Substitute 2. A2 is 5. 5 is equals to
4a plus 4b.
4a
4a plus 2b plus
4a
c.
plus
4
2b
plus
plus
2b plus c.
11 equal to 9 a plus 3b
3b plus
plus
c.
c equation number 3. First 2 minus 1 చేయాలి. 2 minus 1 చేస్తే 4 is equals to
3a plus b is equals to 5, sir.
3a plus b
and 3 minus 2 gives you 11 minus 5. 6 is equals to 5a plus b. Now subtract them. Minus a. 2 is equals to 2a. Implies a equal to
1.
1. A1 first దీంట్లో పెట్టండి. Since a1 పెడితే b కూడా 1.
B is equals to 1.
A1 B1 substitute in first equation. A1 B1. C minus 1. C is minus
is
1.
minus 1.
So finally AN is equals to 1 into n square plus 1 into n plus minus 1. This is AN. Then A10 is asking 10 square plus
109,
10
sir.
minus 1. 109.
Sir, A
Yes,
is
sir,
minus
109.
1.
Yes?
Sir, how 5 equals to 4a plus 2b?
Sir, minus 5 plus 3a. So minus 2a.
No. Here minus 2 there. Minus.
Sir,
Yes, sir.
3a minus 5a. Minus 2a.
Minus 2a.
4 minus 6. Minus 3. Minus.
Minus
Okay.
cancel.
How we write 5 equals to 4a plus 2b plus c, sir?
Run this.
Sir, how you got 5 equals to 4a plus 2b plus
a2. a2.
Here written now. కనిపిస్తుందా నీ బోర్డ్ క్లియర్ గా 3 minus 2
Subtract.
equation 3 minus 2. One homework question madam. Fibonacci sequence we call this. This name only. The Fibonacci sequence is given that an is equals to an minus 1 plus an minus 2. N is greater than 2. And a1 is equals to 1. a2 is equals to also 1. Then an plus an plus 1 by an for n equals to 5. Find out this value. Indirectly a6 by a5 into 5.
Okay.
Try this and then tomorrow. This is also one of the sequence. There is a name that's it. Here, this is one of the sequence. This name is Fibonacci sequence. So this sequence, first term, second term is given. Then you find out a6 by a5. That's a sequence. The help of this sequence, let us define the progressions. Till now we observe the sequence. In the sequence, terms does not follow any pattern. Terms in whatever order, just terms in the sequence are defined with one explicit formula, one nth formula. It not follow that the certain pattern. Sequence or terms of a pattern follow. It is not necessary. Follow, but it depends on the terms. Nth term batti sequence can have. But in progressions, the terms of the sequence must be follow a pattern, either in common difference something, or common ratio something, or reciprocal common difference something, like that. There are 3-4 progressions are there. AP, for example, if you take it follow one pattern that the difference between two constituent terms is constant, or the terms in the sequence are increased by a constant or decreased by a constant. Each term. That the sequence follow one pattern. That is called the arithmetic progression. Similarly, we have a geometric progression definition. The consecutive terms ratios is constant. Understand the definition of the AP arithmetic progression. First one is this AP arithmetic progression. The terms in the sequence follows one of the pattern. That pattern is the terms are increased by a constant or decreased by a constant. Other words, the consecutive terms in the sequence or in the series, difference is constant. The consecutive terms, పక్కపక్కన ఉన్న terms లో ఏవి తీసుకున్నా గానీ difference calculate చేస్తే same రావాలి. That is called arithmetic progression. Usually we take that the arithmetic progressions are like a plus d,
A plus D,
a plus 2d,
2D,
a plus 3d,
plus 3D,
so on, a plus n minus 1 into d.
plus 1 into D.
You see the terms, The consecutive terms, if I take these two terms, the difference between these two is a D. The difference between these two is also D. The difference between these two also D. That common difference we denote, we call as the common difference. Here we call that D as the common difference. And A is the first term of the AP. And N is the
AP.
number of terms of the AP.
Number of
AN is not.
But that's a definition. Let us observe some point here. The first point is that the general term or nth term of the AP denoted with Tn. A plus
N minus
1 into D. Usually we denote here the nth term of the AP with the capital Tn. In this A plus n minus 1 into D, A is the first term, N is the number of term, D is the common difference. You have to know all the what are the notations we did. Okay. Then the next point we can observe here. In general, if you know the nth term, how do you find out the common difference? See,
A2 minus A.
Tn plus you know the general term. That's it. Yeah, Tn is Tn plus 1 Tn. Let's do it. What we get? Tn plus 1 is what? A plus n plus 1 minus 1
n
into
plus
D minus Tn is
A
A plus n
n
minus 1
minus
into D.
1 into D.
So A gets cancelled. Now this is nd and this is n minus 1 nd. So n minus or minus plus 1 into D. Then n cancel. Hence we are getting the D. So finally you can say the second observation Tn plus 1 minus Tn, we get the D, the common difference.
Yes, sir.
Nth term Tn, sorry. The consecutive terms నుంచి ముందు నుంచి దీన్ని తీసేస్తే మనకు D వస్తుంది. Generally you can prove like this. This is the next observation in the arithmetic progression. Like that, we have many observations. In tomorrow class, I'll discuss that. Let's do
Tn
some
is
basic
last
questions. Yes.
Tn is last term.
Yeah, Tn is last term, or you can call the general term, or you can call the nth term.
Okay, sir.
Like that, we have some observations to discuss.
So we can write AN also, sir.
So we can write AN also for Tn.
Even
Yes, sir. AN.
AN.
AN is
Instead of
also in a
TN,
last term,
we
right?
need
Sir?
to use AN also, sir.
you can use no problem. In some of the book, written AN also. Okay.
Yes, sir.
First example, write on all of you. Write the example 1 on the definition of AP. 11th term of the AP. Find the 11th term of the AP. Find 11th term of AP. AP is 5, 8, 11. So 5, 8, 11, so on.
35, sir.
32, sir.
Answer
35.
35, sir.
T11 is 35, is it?
A plus 20.
Yes, sir, 35.
35, sir.
5 plus 10 into D. D is how much?
35.
Since 5 plus 10
10
into 3.
into 3.
Next
equal to
example. How many terms are there in AP? Example 2. How many terms are there in AP? How many terms are there in the AP? 3, 7, 11, 3, 7, 11, so on. 407. In this AP, how many terms are there?
Sir, we need to find N, sir. A 407 equals to
100, sir. 100.
Sir,
102.
102.
102,
sir.
102, sir.
How many terms are
Not
there
two,
in
sir.
this equation?
102, sir.
102, sir. 102.
Yes, sir,
102.
102.
One or two, sir.
102, sir.
407 is equals to 3 plus
3
n
plus
minus
N
1
minus
into
1 into 4.
404 is equals to
N
n
minus
minus 1
1
into 4.
into 4.
N minus 1 is equals to 1 0 1.
1. Yes, sir.
N is equals to
102.
102.
Next example. Today only basic things I'll discuss. Koద్దిగా tomorrow కొద్దిగా dose చేస్తాను. The basics are first మిగతా వాళ్ళకి ప్రాబ్లం అయింది అందరికి కొంతమందికి రావచ్చు కొంతమందికి రావచ్చు. Right. Next example in AP 5 times of the fifth term 5 times of the fifth term equal to 8 times of the eighth term.
Repeat the
5
question.
times of the fifth
15th
term.
term is 0, sir.
Listen. What is it? What is your answer?
15th term is 0.
What question? What is it? Okay. What do you read? Fifth
Sir,
term,
can you
5
repeat the
times of
question?
fifth- yeah. 5 times of the fifth term is equals to 8 times of the eighth term. Then find the 13th term.
Sir, can you repeat the question?
Exactly, yeah. 5
3a plus
5
36
times of the fifth term
equals
equal to
0.
8 times of the eighth term. So find the 13th term.
Sir, which term?
13th term. 13th.
0, sir.
Good. Answer is 0.
Sir, 0.
Yes, sir.
Like this. 5 into fifth term a plus 4d is equals to 8 into a plus
A plus 7D.
7d. 5 and 3a. It is 3a. And how much?
Minus 36D.
Yes, 36D.
56 minus 20
Minus 30.
36, sir.
plus 36d. Then
Yes, sir.
common entada?
Yes, sir.
The common is the a plus
12D.
A plus 12D.
12d.
A is equal to
a plus 12d equal to 0.
A 13 is equal to 0.
equal
T 13 equal to 0.
yes, sir.
Next example. Pth term of the AP is Q. Pth term of the AP is Q. Pth term of the AP is Q. And Qth term of the AP is P. Qth term of the AP is Q. Qth term of the AP is P. Then find nth term. Nth term. Then find nth term. PP is equals to Q. PQ is equals to P. Then Tn is equals to dash. Okay. Right. Do this one homework and one more Fibonacci question. That two questions. Right. And something like that. Okay. Today class only basic part of the progressions. Okay. The extension level. Report class. Right?
Okay, sir.